Hi everyone, this is Mazik Bal again here, and today's video is going to be about a dual RCD consumer unit, which is also called split load consumer unit. Just wanted to touch about what we discussed so far in the previous video. We already discussed about overload, our current protection via MCB, and obviously how MCB is going to behave in terms of fault condition, where we got higher out fault loop impedance, and how this can have it will impact on customer side is the faulty circuits. We've got issue with our circuits. We also discussed on earth leakage, where we obviously we don't have a short circuit and our current problem, but we got a leakage problem where our MCBs won't detect it, and it can be a problem. And in those circumstances, we're going to be using RCD consumer unit or RCD device, which is going to detect this earth leak. And RCD works different to MCB. MCB detects overload, our current short circuit, whereas RCD 30 milliamp RCD I'm talking about, it will detect imbalance between the phase. If there is what I mean by phase, if there's a 7 amp coming to our any appliance we're using, and if it's 6 amp going back to the consumer unit, back to the system, then there is a 1 amp leakage, and that 1 amp leakage is it's dangerous. That could cause that you can be electrocuted, and it could be a bit of a problem in if you are in contact with the ground at the same time, if you haven't got a RCD circuit, RCD protected circuit. It's not going to be amazing, and sometimes you don't have to be in contact with the ground, but you are indirectly in contact with the ground, such as you got a metallic pipe coming to your water supply, your gas meter, your water meter, and then you've got a proper copper pipe installed that could be linked to your tab, and is you are, if you are in contact with the faulty plants at the same time, you are in contact with the ground, indirectly with your piping system in home. This is where you can have issue, and it will, the fault is going to go through your body to the ground, and this is where your MCB, it's not going to protect you. You need to have RCD protection, and it will detect earth fault, and you don't have to go through this, to wait till your current go through your body and it will trigger. Now it's not going to be a problem. In this, RCD will trigger as soon as there is a leakage, because if the leak is already there, you are in contact with the faulty appliance, and then you get electric shock. But yeah, if it's RCD's protector circuit, then obviously as soon as there is an imbalance in between the phase circuit, in between the phase, that's where the RCD is going to trigger. And you don't have to wait to touch your appliance and that you get electric shock, then it will trigger. No, that's not going to be the case. We will discuss about RCD protection in this videos, and I don't want to discuss about too much about different type of RCD at the moment, because we are going to be using 30 milliamp RCD. This is what we use in domestic property, and I know the TT system is RCD under damp. RCD is used for fault protection, but now in this scenario we're going to be discussing about 30 milliamp RCD. But before we discuss about RCD, I will discuss a different level of protection we achieve when we do electrical installation, or when we do electrical installation condition report. So this is where we need to make sure we got a basic protection there, fault protection there, and additional protection there. Okay, let me explain what is basic protection. Basic protection is physically what you can see. If there is any socket switch consumer unit, you can see there is some damage there. It's broken, cracked, and live parts exposed, and they're accessible. That's, we can say, it's a basic protection failure. But there is a different terms used in BS 7671 in electrical installation regulation, what we use here in UK. So placing out of reach live part, and this is another one. So that could be some time we could say overhead transmission line. So yeah, but in domestic property, I would say if you got any broken accessory, any electric accessory such as switch socket and is accessible, live part inside the accessible, this is a basic protection failure, and there needs to be a remedial work need to be carried out, or withdraw the or disconnect the system or circuit, whatever. Live parts is the defective part till that is fixed. So this is basic protection. The fault protection is a different level for protection. If you have your circuit is physically, you can see there's nothing wrong, and but there is earth circuit protector conductor missing, such as your got a radial circuit. It could be a situation where your circuit is installed on a ground floor and you are using your vacuum, sometimes you're using lawnmower outside, and you connect your lawnmower, electric lawnmower, to your socket, and there could be a problem because you haven't got circuit protective conductor in your circuit, but a continuous circuit protective conductor, that's what I meant. You probably got cable to in another cable, but it's disconnected, it's not continuous, broken, or loose. This is what we call a fault protection. There could be other reason as well, but this is just to give you an example. And additional protection is this is where the RCD is going to be a 30 milliamp RCD. We're going to be discussing in this split load consumer unit. Additional protection will be provided with the RCD if there is a problem with the circuit protective conductor, such as if there is earth leakage, as we said in MCB consumer unit. We had 8.69 amp coming to the appliance microwave, and it's 7.69 amp going back to the system, the consumer unit, back to the transformer. But here, the one amp was missing, and that 1 amp is dangerous if there is a problem in MCB consumer unit. If circuit protector conductor is not there, or there's something wrong with your circuit protector conductor, and it hasn't got route back to the system consumer unit. This is where you're going to have an issue. Yeah, obviously you will get electric shock if you're in contact with the appliance and at the same time with the ground. You don't have to be in contact with the ground. If you got any other, yeah, I mean, there could be something buried inside the ground. Sometimes you have got your gas pipe, you have water pipe next to you. This is where you're going to be if you are in contact with the gas pipe and water pipe. You got direct contact between line and the ground, and this is where you can get electric shock. Yeah, but yeah, if you got RCD there, RCD protection there, obviously it's going to detect the fault. We don't have to wait till your circuit protector conductor is disconnected from the socket switch or not continue. It's going to start tripping because the current coming to the appliance is 8.69 amp, and going back to the system is 7.69 amp. So this is where there's an imbalance. Just 30 milliamp RCD, this doesn't detect short circuit and overcurrent. This works differently. It works earth leakage, if there is any leakage, if there's an imbalance between line and neutral circuits current carrying, if there is imbalance in between the current, that's where the RCD is going to detect and interrupt. So if it's an imbalance, I mean the current is going through your circuit protector to the system. So this is where RCD is going to trip. So you don't have to touch the appliance, to feel it, because it's already there. RCD is already there. You detect the imbalance. There's a leakage. It's like a water pipe. You got a water pipe. Sometimes you try to tie up with your tab, but it's still dripping or leaking. So, but this leak sometime, obviously, that's going to be a problem in the electrical system, and this is where the RCD is going to detect. Okay, I think I've explained about RCD protection, but I don't want to get into too much into RCD. There's the different RCDs, but yeah, in terms of, I'm just going to discuss about 30 milliamp RCD. We know the 100 amp RCD that works on TT system for fault protection at the origin of the installation. But here we're only going to discuss about 30 milliamp RCD is a split load consumer unit, and we'll look into it. How is that going to save us from electrical shock? Yeah, let's dive in. Oh, hi everyone. Yeah, this is a split load consumer unit. I've just made one now, and I draw it out here. But yeah, as we can see here, we got this double pole man switch here, and next to the man switch we got RCD. There, sometimes you do find a bus bar under there, and you find there is a gap in between there where you can put your MCBs that could link your SPDs, but in this case we got a SPD there, so that's could be this MCB that could feed to this SPDs, and obviously we got if we then we're gonna have a neutral cable going to the neutral terminal, such as this one here, and then we'll have a earth cable, connected to the earthing terminal. Yeah, and we got this 30 milliamp RCD. This is a split load consumer unit, as we can see here, and we got three MCBs connected to this RCD. So we can clearly see here there's a bus bar under there that linked these three MCBs, and at the same time we got another another RCD there, 30 milliamp RCDs, and that connect these three MCBs. Okay, so yeah. Then I'll just use the same the previous example about this cable and the microwaves. Yeah, that's your normal socket circuit. Yeah. Now we got this cable. Obviously, this RCD need to get live connection. So to get live connection and then feed it to this MCB. This is where this is going to be from your double pole isolator, the man switch, the terminal, the live conductor, the live side is going to feed to your RCDs, and from RCD sometime you find another cable there that link to this RCD, but sometime this loop into from RCD to RCD. So in this case we got this RCD's live cable going to this RCD, and from there to loop into another RCDs. Okay, now we got neutral as well. Obviously neutral need to feed to the system as well. So the neutral cables from the man switch is gonna go to your man neutral terminal. It's gonna be connected there, and from there we're gonna have incoming side of the RCD neutral cables connected to the RCD neutral terminal. Yeah, as we can see here, this neutral cable, obviously this neutral cables, the system, the meter tail is going to be connected up there, and the neutral cable is connected to neutral terminal. So this is where this RCD is going to be connected, and you will get the neutral connection there. The bottom end of the RCD is connected to the neutral terminal. So this side of MCBs, they're all going to be connected to this side. So obviously if it's connected to this side, then there's going to be a problem, and they're probably going to be a less voltage. Sometimes they trigger the trip. Yeah, you got to make sure you need to use these MCBs. Don't by mistake don't install into this neutral terminal. This, if you install into this one, then it's going to be a problem. Yeah, but they need to be installed in the right neutral terminal. Okay, in Sam with this RCD we can see here we got the neutral incoming neutral side here, and now the bottom side is feeding up there. Okay, now this RCD is feeding to this socket. We can clearly see neutral is connected there, and circuit protective conductor such as the CPC, that's earthing conductor to connected to this earthing terminal. Yeah, that's what RCD's dual RCD consumer unit is going to look like. Yeah, and now we got this, yeah, TNS systems, and we got meter on top there. Now we got line conductor, which is connected to the meter, and then a neutral, and we got this cable from meter to feeding to our live side of the line side of our double pole isolator, and neutral is feeding to the neutral side after this double poles man switch. Yeah, we got earth a cable as well, main earth, the distributor earthing conductor, which is going to be if this is a 25 mil cable, that could be a 16 mil. This is what should be normally, so, but yeah, this is going to be connected to earthing terminal here. Then I've just added this, from previous video. This is going to be this is just to give you example about, this is not transformer, but just look like a transformer. Just think this is like it's just your domestic. This is a transformer for domestic supplies, so that could be somewhere down the road. Yeah. Okay. All right. Okay. In this dual port RCD consumer unit, as we said, we got this RCD which is connected to this socket, and if there is any earth fault, anything wrong with the consumer with this appliance, and if there is a leakage, this cable is damaged, if it's in contact with metal body of this appliance, obviously then there's going to be a leak. If it's a damage, it's not adverse situation where it's completely damaged. There's a slight leak. It might be internal element sometime, but yeah, in those circumstances where isn't, as I given an example previously, there is the water. Sometimes you tie your hose for your garden. The garden. You want to use the water in the garden or probably in the front of the driveway to wash your car, and there is a slight drip by your tab, so this is where is a current leakage. Okay, so as we can see here, this from this example, this is current coming to this appliance. In this example, as I said, it is if we can think about the water pipe, there's a two water pipe, and there's the third one is circuit protector conductor. There's a three layer, so there's the third one. I said there's going to be these two pipe within the pipe, so you can think this is a line. This is bringing current to your appliance and microwave, and when this is used, going back to the system. But at this point there is a slight leak. There's 1 amp leak which isn't going back to this neutral cable, and it's leaking, and it's going back to the system via your circuit protector conductor. Yeah, like I said previously, we got 2000 watts, which is 2 kilowatt microwave, and in the UK we have 230 volt supply. If we divide by 230 volt, we get 8.69, and obviously you can add this number, you can make it to 8.7, but yeah, this is what this current is going to come to this appliance, and it's going to go back to, obviously, if it's going back 7.69 amp, there is 1 amp. This is where the 1 amp is missing, and that's going back to the system via this circuit protective conductor in this in this example about this circuit protective cable CPC. This is where this is going to go back, instead of coming to here, it's going there, and from there going to the system, back to here, back to there, and back to the RCD again. But this RCD is going to detect imbalance, obviously. If the current is 8.69 amps coming to the your appliance, and if it's 7.69, there's 1 amp missing. This is where the RCD is going to detect the imbalance. This works differently. So as I said previously, it's not going to detect our current and short circuit. It's going to detect the imbalance. So there is an imbalance, there's a leakage, earth leakage, which is going through the your circuit protector conductor to the system. So, but yeah, this is where the RCD trigger, and it will trip and will disconnect it will disconnect the circuit where you got your faulty appliance, and it won't work till you switch off your disconnect your or unplug your microwave in this case. Yeah. Okay. Okay, well, it's good, it's fine, and we know the RCD is very, I mean, it's going to protect you, it's going to give you additional protection, and it will carry on tripping till you diagnose the fault and rectify. You can turn off your electric. It's not going to be, obviously, in those circumstances you wouldn't have electric, but here we got a problem with the RCDs. What the one problem we can see here, because this RCD is feeding on these three MCBs, so the bank of three MCBs, so such as in this case we got a downstairs socket, and at the same time we got a cooker circuit, but probably this is the cooker MCB, and we got upstairs lighting. If there's a problem with this microwave, so we want this MCB, this circuit, this circuit to be obviously that should trigger and that should trip, and the rest of the electric shouldn't have a problem, that it doesn't have impact on these two MCBs. But this is where RCD is lacking, and you will have an issue if RCD trips, because this fault within this socket, it will have impact on these two MCBs as well. Obviously you will lose your upstairs lighting and cooker. In worst case scenario, if you got your socket circuit connected to your, sometimes you have a ring man, your radial circuit, and your heating system is connected, such as your boiler is connected to your socket circuit, you're not just going to lose your electric, half of the electric in your house. You will have no heating as well. So this is where it could be a big problem. So another issue I can say, if you gotta be very careful, you need to check every 6 months by pressing this button. This is a test button to make sure this mechanism inside the RCD, that trigger, if it doesn't trip, that's mean you got RCD, it look well, nice, you got a nice consumer unit, but in fact it's not working. So if there is a fault anywhere here, it won't, if there is earth leakage, it's not going to detect. Obviously it's dead, it's not working. So no problem is within this circuit, if it's a socket circuit. So I mean, you got other three circuit as well, two circuit connected there. There could be a problem in this case we had a socket, there could be a problem in this one or any circuit, but these all three circuit, they connected to this RCD, and there's no protection because this RCD is dead. So this is where I would say this is a drawback about dual RCD's consumer unit. Another thing we need to make sure, obviously, that all these appliances we use in the house, you find there's a slight leakage. If you use a clamp meter to check, you're probably going to see your microwave kettle, your kettle, your toaster kettle, excuse me, fridge, freezer as well, and they all leak some, the in a milliamps, probably some, sometimes it's less than 1 milliamp current. That's all going to add up. If you got in this case we haven't got a big consumer unit. If you have got half of the appliances are your all appliances connected to this side, so they're all gonna leak around your microwave, your cooker, um, your washing machine, your tumble dryer, your fridge, your freezer, your toaster, kettle. If they all gonna lose, because some sort of there's gonna be a leakage, earth leakage, and that could be if this is board. Um, and I mean, if you've got 4 or 5 more circuit there, if this all add up, and that's going to be a problem. That's these hard people going to be triggering you. It's very hard to find a fault if there's those circumstances. Obviously, it's not one appliance which is causing a problem. It could be a multiple appliance where this is a leakage that's all adding up. Even though this is 30 milliamp RCD, it could trigger on 21, 22 or 23 milliamps. So it doesn't have to reach to the limit of the 30 milliamp before it trigger. So yeah, this is where we can have issue. So it's the same this side as well. If you look on this side, if you got obviously you're going to have a few circuit connected this side as well. Sometimes this RCD can trigger, and this is working fine. In this case, you're going to lose obviously half of your board is going to be not working. You will have no power, and you probably in the same time you probably have no heating as well. And this is where you can have an issue. But yeah, if you got a big bird, yeah, if you got multiple RCDs, probably third RCD there as well, to avoid earth leakage. If you got more, all kitchen appliances connected to one side, if you can have another RCD in between there. But then again, your total leakage of this side shouldn't exceed 9 milliamps. That's what they're in the reg. So if it's a 10 milliamp, obviously that's not good. Yeah, it's on this side as well. Yeah, okay. This is yeah, RCD consumer unit, and obviously it does give you protection, and there's only drawback I can see here is it's not giving you segregation. So obviously, if there's a problem with this circuit, in MCBs, the problem with this MCB, that's going to trigger, that's going to trigger with the RCD. Obviously, they will have impact on this side as well. Okay, this is where we'll discuss about how we can, how we can overcome about this sort of situation, to avoid nuisance tripping, and sometimes it's a bit difficult to pinpoint which circuit is causing a problem. Okay, but yeah, in the next video I will discuss about RCBO's consumer unit. I will leave it here. Don't want to get into RCB consumer unit on this video, but yeah, I will discuss on this next video about RCB consumer unit. How is that going to be different to MCB and RCD's consumer unit? Thank you.